In a previously posted video, you can see the link in the description below. I've posted how to create a truth table. I've talked through the details of the methodology for doing this. Here, I'm just giving an example of an invalid argument and how you can use a truth table to show that an argument is invalid. The argument that we are going to consider is here. So we have two premises. The first, if apples were units of money, then apple orchards would be heavily guarded. Second premise, apples are not units of money, and we draw the conclusion that apple orchards are not heavily guarded. Now, initially, this seems like a plausible argument. It seems like the reasoning is fine. However, if we are considering this to be a deductive argument, it is invalid. And to demonstrate the invalidity, we can construct a truth table. Now, first we have to represent these sentences. So we use simple sentence letters, P representing the sentence, apples are units of money, and Q representing the sentence, apple orchards are heavily guarded. And with those simple sentence letters, we can represent our argument. So we have the if P then Q, the P arrow Q, if P then Q, and we have those two sentences arranged in that relationship. If apples were units of money, then apple orchards would be heavily guarded. And then we have not P, the denial of the claim that apples are units of money. And so we have apples are not units of money. And our conclusion is not Q. Apple orchards are not heavily guarded. Now, in order to evaluate the validity of this argument, we can construct a truth table, and we have two simple sentence letters, P and Q, and we start, as is common, with the right-hand sentence letter, Q, and we just alternate down the column TF, TF. Then we go next to the left with our sentence letter P, and we alternate by twos, TT, FF. And this will give us all possible combinations of truth values for those two sentence letters, both true, P true and Q false, P false and Q true, and then both false. Next, we have a column for our premise, if P then Q, the first premise, and we just go through and fill that out. If P and Q are both true, the conditional is true. In the second row underneath the sentence, if P then Q, we have a true antecedent, but a false consequent. And in that case, the conditional is false. In the other two cases, the antecedent is true. And so both cases gives us a true conditional. And then in the next column, we have not P. And so we just put in the opposite truth values of what we have on the far left column for P. So false, false, and true, true. And then we have not Q. And we just do the opposite of the truth values for Q. So false, true, false, true. Now we can evaluate the validity of the argument because we have a column for both premises and a column for the conclusion. And we look to see, are there any cases in which all the premises are true, but the conclusion is false? And we see, in fact, there is a row with that, highlighted with the red ink here. And so we have a case where we have true premises and a false conclusion. And in that case, the argument is invalid. So the truth table as a whole shows that this argument form denying the antecedent is an invalid argument form.